Okay, welcome back to the next lecture on data analysis. In the very first part, we explained how to analyze equations, and in the second part of this lecture, I took a particular example. We did an analysis, and then we saw how the table has to look like, and then we moved on to the graph, and I explained some very important things on the graph. And I said that you don't try to make your work neat by, if this is your full graph paper, you don't try to make the work neat by moving one square inside on the graph paper and maybe moving one square inwards from the x-axis or the y-axis. Okay, you come at the very edge of the graph. If this is your graph, if this is the area where you have to plot the graph, you come at the very edge and you put your y-axis, and at the other edge you put your x-axis. Okay. Now, another very important thing which I'm going to explain to you about the graph, and this is going to be very, very important in June 2014 if you have the physics paper, because we are used to plotting graphs that we have y-intercept this way and then the x-intercept, the y-axis like this and then the x-axis that way. Remember that the Cartesian equation has 4 quadrants. The Cartesian equation has 4 quadrants. Okay, remember you write your point as xy. Okay, and in this region, if this is y and this is x, in this region here, x is positive, y is also positive. This is the first quadrant, and in the second quadrant, x is negative and y is positive. In the third quadrant, y and x are both negative. Okay, x is negative, y is negative. And in the fourth quadrant, x is negative, x is positive and y is negative. Okay. Now, if you happen to have the values of, maybe let's say ln e, if ln e is positive, okay, and ln c is also positive, it means that this is how your graph is going to look like. So on your graph paper, if this is your graph paper here, let me just draw a small demo this way. Okay, so that I can be able to indicate on it. Now, if this is your graph paper this way, with your squares on it, alright, if my y value, what I have to plot on the y-axis is positive, and my x is positive, it means that my graph, I will start my graph this way, my y-axis will be like that, and my x-axis is going to be that way. Okay? Now, what if my x values, I'm supposed to put on the horizontal axis, are negative, and my vertical values are positive? I will not try to modify my graph because my graph will not look like this. It simply means that the graph is going to fall in the second quadrant. So if the graph is supposed to fall in the second quadrant, it means that, okay, my y-axis is supposed to be this way. My y-axis is going to be this way, and then my x-axis, alright, will be like that. So that when I put my values on the horizontal axis, they will be negative. Okay, I'll write them like this negatively, and then my y values are going to be positive. Alright. Now, what if both the values of ln e and c are all negative, ln e and ln c are all negative? If ln e is positive and ln c is positive, is a normal one that you always plot. Okay, y and then x. Okay, from here you can actually be able to see like this. This side is going to be on the graph paper. But now, if the values of ln e are positive and that of ln c is negative, it means that you are supposed to plot that of ln e is positive and that of ln c is negative. You are going to plot it like this. Okay, so ln e is going to have positive values and then ln c has negative values. And that's just an example. Alright, in any case you encounter it, because you encounter such a case in June 2014, data analysis. Now, what if both values are negative? If both ln e and ln c are negative, it means that, alright, my graph must not be that way. Okay, so what happens is that I am going to have, it means that the graph is going to fall in the third quadrant. Okay, it means that the graph is going to fall in the third quadrant. So it means my y values, okay, my y axis, yes, this is my y axis, but I'm going to have values in the negative region. Alright, so this is my y axis here. Alright, and then if this is my y axis, then my x axis is going to be like this. If both the values of ln e and ln c are negative. Okay, if both the values of link E and link C are all negative, my graph is going to fall in the third quadrant, and so my x will be this way, negative, and my y will be also negative that way. Okay, now what if x is rather positive? All right, that means that if link C is positive, because link C is the one that is going on the horizontal axis, and my link E is negative, what is going to happen? It means that y is negative and x is positive. So it means that the graph is going to fall in the fourth quadrant. So it means that y is negative, so y will be facing downwards. Okay, while my x is going to be moving in this direction, and that's this quadrant. This is how the quadrant is going to fall. And I think for that value of for the values of the equation, all right, for June 2014, I think the graph fell in the fourth quadrant. Okay, so please take note of this and make sure that you know how to plot. All right, you follow the rules. If you see one of the values to be negative, one is positive, you should know that it can be found. The graph can be found in any quadrant. All right, so that is it about that. So you can always replay back the video in order to understand what I just explained. But now in this our case here, if you take the values of link E against link C, all the values of link E and link C are positive. They are not negative. Okay. So since they are positive, it means that my graph is going to fall in this region. Okay, where I have my link E here plotted against link C. Okay, I have my link E plotted against link C. So after you have put your axis, okay, you label your axis. So the very first thing on the graph is the axis. All right, you label your axis. The y-axis is link E in this case, and link C in this case. All right, and the x-axis is link T in this case. In other questions, you are going to have you make sure that you label it correctly. Now I've labeled it. The next thing is for me to choose my scale. Now remember our equation, the graph we are plotting here is link E equal to n link C plus link A. Alright? So we are plotting a graph of link E against link C. And what happens is that link A is going to be the intercept. But you see, your graph is not as convenient as in O levels, because in O levels they can give them graphs that can always start from 0. But with you here, you might not necessarily start your graph from 0, because if you start your graph from 0, you are going to have a poor graph. Your graph might be hanging, because when you start from 0, by the time you reach the value where you are going to plot the first value, or where you are going to do the first plot, okay, you already maybe be somewhere very, very high up there. And sometimes you can draw your graph is either hanging like this, or maybe you can have one graph like this somewhere, and it is very poor. Now your graph that you are plotting must cover at least 3/4 of the graph paper. Okay, must cover at least 3/4 of the graph paper. So the next thing after the axis that you do, okay, is to choose the scale. All right. If you have a poor scale, you are going to lose the mark. A good scale is very important. Now you cannot use 1 square to represent 3 units. It's a very poor scale. Okay, 1 square to represent 3 units is a very, very poor scale. 1 square, for example, to represent 5 units, all right, is better, because within 1 square you have 5 different sub-squares which are found within it. So you can be able to take one maybe to represent one value. Okay, one of those small squares to represent one value, so it is good. But you cannot take 1 square to represent 7 units, or 1 square maybe to represent 1 square to represent 7 units is a very poor scale. You cannot take one square to represent, let me say 9 units. Okay, it's a very poor scale also. Okay, so please now the hints. How do you get the value of the scale? All right, how do you get a hint to know how your scale should look like? As I said, your x value here, your link T value and your link Y value must not necessarily start from the same. Okay, it's not if my graph here, if my link T value here starts from 1, link E must not necessarily also start from 1. Link E can start from 2. Okay, and link T can start from 1. No problem. I use this one will be a completely different scale from this other one here. So their scales are not going to be the same. And as I said, if you think that your link C value can rather fit the longer length of the graph paper, then you go for it. You turn the graph paper, you put your Y, then you put your you put your y-axis like this and then your x that way. Okay, there is no law that says that this one must be the y-axis and that's the x-axis. Now the next thing that I do for me to get, so I'm going to take the highest value. Okay, please take note. So I'll take the highest, if I want to, because on the horizontal scale here you might have something like 18 squares. Okay, you can have about 18 squares. So what I do is that I'm going to take the highest value of ln t, which I find on my table. Okay, well, because we are going to have the table of ln t here. Take the highest value of on the table minus the lowest value. When you take the highest value, so take highest value minus the lowest value divided by number of squares. Okay, highest value minus lowest value divided by number of squares. For this one, I'm going to take the highest value of the t minus the lowest value of the t, and I divide by the number of squares which are here. Now, when you divide by the number of squares, it will tell you what exactly one square is going to represent. Now, if it gives you a value of 0.2, all right, and say for example that the lowest value of ln t was say 1, all right, was 1, and maybe you took the highest value minus the lowest value and divided by maybe 18 squares and gave you 0.2, it means that one square can represent approximately 0.2 value. Or if you gave you something like 0.21, you can just leave it as 0.2. If you gave you something like 0.29, you can round it up to 0.3. Okay, now if it is 0.2 and my lowest value is 1, it is not advisable for you to start the graph from 1. Okay, it is not advisable for you to start the graph from 1. Start maybe a value which is a little bit lower than 1. And if you are starting like that, you can use a value maybe let's say like 0.8 in this case. Okay, so that if this is the next square here, if this is the next point here, I can take 0.2 because one square represents 0.2. So if you take 0.2 and add to this 0.8, you are going to have 1. Then the next square will represent 1.2. The next square will represent 1.4. The next square will represent 1.6. This is just an example. So if you have your value for one square being this, it means that the value you are going to start with here should be a little bit lower than the very first value which you are going to have from your table. So after each, it means that after each value, okay, after each value you add 0.2. So you see the interval for each square here is 0.2 units. Okay, telling us that one square is representing 0.2 units. Okay, so that is it. You do same for the scale for ln e. You take the highest value minus it, the highest value minus the lowest value, and divide by the number of squares on this side. And the number of squares, I think on the vertical side is about 22. But if you divide by, let's say, by about 20, all right, you are going to get an approximate value for each square on the vertical axis here. And then you're going to start with a value which is a little bit lower than the very first value. Okay. You don't always start with your first value here. You start with a value which is a little bit lower than it, and then you continue plotting. You apply the same principle which I just explained. Okay, so that is that for the scale. That is how you do to get the scale. All right, for your graph. That's a trick that you do. So it does not work all the time, but at least it gives you an idea of what the scale is supposed to look like. And if you want to actually have a mastery of the scale, you can plot as many graphs as possible. All right. You can plot as many, you can decide to plot 10 graphs, 15 graphs. If you plot, let me say 15 graphs before you write the GC, you are going to have a mastery, very good mastery of data analysis, and you can answer data analysis in less than 30 minutes. Okay? So, that is that for the scale. The next thing are the plots. So when you have gotten your plot or your scale, okay, you label, you put your scale, and it is fine. You are now ready to plot. Alright? You now go to your plot. You are plotting your points. Now, when you are plotting your points, okay, of course, you always take the x value, you extrapolate where the y value is, okay, and then you mark it. Now, how do you mark it? I prefer, there are two ways of marking. It's either you mark it with a dot, alright, or you mark it with an x. So each time you mark it with a dot, okay, you try to give it a circle, because you are taking, when you put the circle, it means that in fact, it is the average, alright, it's an average value there. It's going to make your graph to look very good, alright. It makes sure, even when you are doing your calculations, it makes sure, and when you are drawing your best slip line, it makes it to be very, very appropriate, okay. So you can either use an x or use a dot. If you use an x or a dot, you circle it, alright. But I like using dots, and I also like you to use dots too, okay. Now, I have a dot here, Then the next thing is, all right, I'll get another value again, I extrapolate again and I plot with still without my dot, all right, just like that. Then I plot, okay, I take another value again, all right, I plot. So the points to plot usually maybe about 2 to 3 marks, and for every 2 points which are plotted wrongly, 1 mark is off. So you have axis, you have the scale, you have a good scale, you have your mark. Then the next thing are the plots. Okay, plots are usually about 2 to 3 marks. So if you for every 2 points which are plotted wrongly, 1 mark is off. Now I have another point here. I could have, let me say, another point here. Okay, let me say these are my points on my graph. Okay, so yeah, as I said, your graph will not necessarily start from 0. Now the next thing is my best fit line. What we call the best fit line. Best fit line. Okay, my best fit line, because after I've plotted all my points, I now need to connect the points. Now for you to remember, you are drawing a suitable straight line graph. So for me to connect my points, I will not come and start, connecting all the points with a zigzag line. I have to connect them. I have to draw a straight line, okay, through the points. But now I draw what we call the best fit line. We don't draw any kind of line there. We draw what we call the best fit line, which is an average. Because during the experiments, there could still be mistakes. All right, and in the graph, you don't just say the graph is perfect, that they have to fall on the same line. Sometimes your best fit line does not go through any of the plotted points. So your best fit line is a line which is going to have equal number of points on both sides, up and down. All right, so when you draw your best fit line should, okay, it should have equal number of points up and equal number of points below. Sometimes your best fit line can go through 1 point. Sometimes it can go through. It might go through. It might not go through any point. Okay, it might not go through any point, and so it gives you an average value. It is a best fit because it gives you an average value. So if you want to draw it, for example, okay, you make it, sometimes it does not go through a value. For example, if I've just plotted points randomly on the board, okay, there are 1, 2, 3, 4, 5, 6 points here. All right, and I want to draw my best fit line. Okay, I want to draw my best fit line. So what am I going to do? I place my ruler in such a way that I should have equal number of points below, okay, and equal number of points above the line. Now in this case, if I have a line here, okay, if I have a line here, now you see if you draw a line here like this, going through this point, sometimes your best fit line does not go through any point. Sometimes it goes just through 1 point. Okay. If I draw a best fit line here, now this is not a best fit line. Why? Because look at it, has 1, 2, 3 points on this side, and then it has just 1 point on this upper side here, so it does not make it a best fit line. Okay, so what you do is that you place your ruler in such a way that it is going to have equal number of points on both sides of it. So now look at something. If I connect this way, all right, just follow. If I sign this point, then I pass my best fit line through those 2 points. All right, perfect. I have 2 points below the line and I have 2 points above the line. Okay, that is a very good best fit line there because it has equal number of points on both sides of it. Okay, and it's actually going through some points. Sometimes it might not go through the point, but it's that it should have equal number of points on both sides. Like for this one, I had 6 points, and then my best fit line was able to have 2 points on both sides of it. Okay, and it's an average line, and it gives me the best value. Now, it's not just about drawing the best fit line. Okay, it's also about the quality of the line. You should use a sharp pencil, okay, and a ruler. Don't try to draw with a short ruler. Maybe you end somewhere, then you use your ruler again, and there will be some discontinuity. So you should use a long ruler, okay, and a sharp pencil. You make sure that you place the ruler in such a way that you know your best fit line where it's going to be passing, and you draw the line once. The line should be very, very sharp, okay? It should be sharp, it should not be thick. So that's why you should not print. Don't do this, okay? Don't do that with don't print it. Maybe you do something like this. Don't print it, alright? Please, you leave it that way. Okay? Just leave it to be sharp. It should be a sharp line. Just draw it with your pencil, and that is all. Okay? You should be something like this. Just one good line. Okay? just like that. With your pencil, with the sharp pencil, you just go through it. Alright, and that is all for your graph. So you draw your best fit line. The thick, it should not be thick, okay, it should not be discontinuous, you should not print it and all of that, just very sharp. And you are done with your curve, okay, you are done plotting the curve, and that's how you're going to be plotting the curves. Okay, or that's how you plot the graph. This is a suitable graph from where you can be able to obtain the values of, remember our equation was in E equal to n ln C plus ln A. Okay, so you are going to be, when you plot this suitable graph, you can now use this graph to obtain the values of n and A. Okay, you can use this to obtain the values of n and A, right? Because A is a constant in the equation. Alright, so I hope it is very, very clear for the graph part. The first thing is the axis, the second point is a scale, the next point is a plot. Alright, you do the plotting, and after the plotting, you draw your best fit line, and after your best fit, of course, I'll give you the quality of the best fit line. It should not be thick, it should be very thin, drawn with a sharp pencil, it should not be discontinuous, okay, not printed. That's it for that, and that is all about the graph part. Okay, please just take a look at it, and then we are going to continue with how you do your calculations for the grading. Okay, all right, so I hope it was clear about the graph. I've taken my time to really explain to you how you need to plot the graph. In any scenario where you have maybe the vertical value is negative and the other one is positive, you know the quadrant in which you are going to plot. And so that's why I'm challenging you to look at June 2014 data analysis. Data analysis is going to actually give you a clue of what I'm talking about in this equation. Okay, you know what you are needed to do: the axis, the scale, the plots. I've given you a trick to get the scale, the plots, the best fit line. Okay, and then from there we can be able to move on to the calculation of the gradient. So I'm going to leave this one here for now. In the next part of the video, we are going to be explaining how can you use the curve to obtain the values of n and ln A, or A, as most questions usually put it. Okay, how do you calculate the gradient and how do you calculate the intercept, because it is a whole concept on its own. Please, mathematics and physics, this lecture is very, very important. So thank you very much for watching, and see you in the next video. Make sure you subscribe to our YouTube channel to get more information. Thank you very much.